Welcome to Theory of Computation class. I'm going to give an explanation for the conversion of a context-free language to Turing machine. So there are 11 problems are available. Then I will be able to solve 5 or 6 problems for your understanding purpose. So other part of problems you decide and work it out with your own way. So I'm going to take the first problem. So this is the language you want to construct a Turing machine. So what are the procedure for implementing Turing machine from a CFL means there are 4 steps are available. First step is you should write a procedure for implementing the context-free language, and we should construct a transition function table. So tell us a transition function, but we denote the transition function output in a tabularized form. Then depending upon the tabularized notation, we should draw the transition diagram of a Turing machine, and we should validate the input string with the construction of table. So by using the table, we'll just validate the correct input string. If it is a correct input string, the table should go to final state. So this is the step-by-step procedure for implementing Turing machine. So here, consider L value. So the set of strings are 0, 1, 0, 0, 1, 1, 0, 0, 1, 1 like that. So what is the procedure means? I just think about the main logic for construction of Turing machine, in which all the strings contains equal number of zeros and ones in it. So if control head read 0, I want to replace 0 with X symbol, because Turing machine contains infinite length of tape. So this is an infinite length of tape in which few cells will be filled with some values, other notations are filled with blank space. Here I am using blank space as this notation. So instead of capital B, I am using blank space with this symbol here. So the main logic behind the Turing machine means we should replace all the symbols on tape. So we should check the equal number of zeros. So if 0 is read, it will be replaced with X. Then I go to read the first one. Then it will be replaced with Y. Then again second 0 with X, second one is Y. Then if you check the symbols on tape, all the zeros are replaced with X and all ones are replaced with Y. Then equal numbers are available. Then the Turing machine should go to final state. So this is the main logic behind it. So I write a procedure means if initial state is Q0, the first symbol on tape is only 0. So you just check it out. All the strings should contain 0 only in it. So if the control head read 0 in an input tape, then the 0 will be replaced with X, and I want to check 1. So I want to go to right direction. Then if the current state is 1, if the control head read 1, then that 1 will be replaced with Y. So after replacing the symbol, I want to check the next 0. So the next 0 is only available at left side. So I want to go to left direction. So this is my procedure. So depending upon this procedure, I want to change the value. So second step is I want to construct a transition table. So if you consider tape, so here I store these values here. So this is the valid input string for an infinite length of tape with the current symbol. So infinite length is replaced with like this. Okay. So the initial state is Q0. So the tape symbols are tau is represented as tape symbol. Initially the tape symbols are 0 and 1. And finally the tape symbols are X and Y. So there are possibility of these 4 symbols. Then apart from 0, 1 and X and Y, blank symbols is also available at tape. So there are 5 notations are available. So I use these 5 symbols in one column and my initial state is Q0. So this is the transition table. So I draw the transition table like this. So initially Q0 control head read first symbol 0 with the current input state Q0. So Q0 0 means what is the procedure? I write it as 0 will be replaced as X. So if you consider output contains 3 parameters. First parameter is state, second parameter is the replacement symbol, third parameter is the direction. So this is the way we want to write the output of transition function of a Turing machine. So if you replace a symbol, then you should go to new state. So I go to new state as Q1. Then instead of 0, I replace the symbol as X. Then I want to go to right direction. So this is the way I just remove 0 with X and I go to right direction. Right direction means the immediate cell contains zeros in it and the current input state is Q1 because Q0 state is moved to Q1. So now I am in the second position with the Q1 state and the tape contains 0 in it. So I am in Q1 state with reading 0 as an input symbol. After replacing 0 with R, I only replace 1 with Y. So it is not necessary to change the second 0. I want to check the first one in my tape. So if Q1 with 0 state means you don't change this symbol, just move to next location. So if there is no replacement means you stay in a same state. So same state with the same input symbol, I only move to right direction. So there is no changes. So I am going to third location with the current state. Now Q1 read a symbol 1. I already write the procedure. If 1 is available, you should replace it as Y. If you do a replacement, you should go to new state. So this is replacement. Replacement means Y. So new state means Q2. After replacing, you should move to left direction. So left means after replacing this side, I want to go to left direction. Now I am in a state Q2. So the control head is moved with Q2 state. So Q2 0. There is no replacement. I only go to checking the next 0. So I don't know whether how many zeros are available here. So if I am reading Q2 0, I just only move to left direction. So if Q2 0, there is no replacement. So I stay in same state, only move to left direction. So here Q2 will come. There is no movement. So Q2 read X. What is the meaning? The first 0 is replaced with X. So only move to right direction and this 0 should be changed to X. So in which state 0 is changed to X? In Q0 state only the 0 symbol is changed to X. So if Q2 finite state control read a symbol X with the Q2 state, current state is Q2. So you go to right direction. So I am going to right direction with the starting state Q0. Why? Because the starting state 0 only replacing 0 with X. So that only I moved to old state Q0. Is it clear? Now Q0 X 0. So this will be replaced as X. Right direction with Q1. So here Q1 come. Now Q1 read Y symbol. What is the main logic? Second 0 is replaced to X. Yes, X. So I want to only change the second one as Y. Already the first one is replaced with Y. I don't bother about it. So I only go to right direction for scanning the next immediate one. So I am in Q1 state. That Q1 read Y. So there is no change. I stay in same state and only move to right direction for scanning the next one. So again Q1 1. So Q11 I already wrote the procedure. This 1 is replaced as Y. Move to left direction with the current state as Q2. If Q2 read Y, you just go to left direction only. So if Q2 read Y, only move to left direction. Now Q2 read X means Q0 X, right direction. So now Q0 read a symbol Y. Which means what? All zeros are replaced with X, all ones are replaced with Y. If I am in starting state with reading Y symbol means the process is completed. Equal numbers of zeros and ones are presented and those zeros and ones are replaced with X and Y. That is the main logic. So if the starting state read Y, I want to check there is no 1 in the consecutive locations. So only I move to right direction with the same state because I want to check the consecutive ones with Y. So here Q01, Q0Y, it is replaced. So after that blank space is there. Once Q0 read blank space means you can automatically go to accept state. So this is the main logic of Turing machine. So in a push-on automata, we write it in a input and output notations, but in a Turing machine, we draw it in a tabularized form. That is only the difference. And step 3 is you should draw the transition diagram. So how many states are there? 4 states are there. Initial state is Q0. So if Q0 read 0 means it goes to Q1 state. So if it read 0, it go to Q1 state and 0 with replacement symbol that should be marked here. So the top one is the current symbol and the bottom layer represents the replacement symbol. Then from Q0 to Y, it stay in same state. So you draw the self loop Y, there is no changes in Y. Then for the third one, if Q0 blank space means it will go to accept state, that is QF. So accept state will be drawn with double circle. So the first row contains 3 functions. So I draw 3 output from initial state. Then you check Q1. Q1 contains same state Q1, Q1 with the symbols as 0, Y. So Q1 contains self loop. One self loop with 0, there is no replacement, and another self loop contains the symbol Y. And Q1 go to Q2 state. When it read 1, then that 1 is replaced with Y. Then from Q2, self loop is available for 0, 0 and Y, Y. If it read X, it will go to Q0 state with no replacement. That's all. So how many functions are there? 4, 8, 9. So those 9 output will be drawn as an outpath for this one. So this is the transition diagram. Then validation. So validation will be discussed in next class. Thank you.